In this video we'll be talking about the development of the atomic model. The atomic model is our understanding of what the atom actually looks like. There are a number of different scientists from around the world that have contributed to our understanding of the atom. For GCSE chemistry you only need to know about 4 key scientists. In the 1800s, John Dalton said that all matter is made up of tiny particles called atoms. He said atoms are solid, indivisible spheres. He described them as indivisible, which means they can't be divided any further. They're the smallest you can get. He also said that different elements have different atoms. So magnesium, helium, nitrogen, all of these different elements are made up of different atoms. About 100 years later, in 1897, Thompson discovered the electron using a cathode ray tube, like you can see above. So this straight away disproves the idea that atoms are indivisible because there's electrons in there as well, so there is something smaller than the atom. Thompson came up with the plum pudding model to explain his findings. He said the atom is like a sphere of positive charge, resembling the pudding, with negative electrons dotted throughout the sphere, resembling the plums. You can also think of it like blueberries inside a muffin. The muffin part is the positive charge, the blueberries are the negative electrons. To test the plum pudding model, Ernest Rutherford designed an experiment called the gold foil experiment. He fired a beam of alpha particles to a thin sheet of gold foil that was about 1000 atoms thick. Alpha particles are positively charged. Most of the alpha particles went straight through the gold foil. Some of them changed direction, they were deflected. Very few of them came right back at the source. They were deflected by 180 degrees. These results were quite surprising because according to the plum pudding model of Thompson, they expected all of those alpha particles to go straight through because the positive charge was so spread out that the alpha particles would not be deflected by repelling the positive charge because it was so spread out. However, like I said, what actually happened was although most went straight through, some of them came straight back at the source and some of them were deflected by large angles, as if there is something in the center of the atom, which we now know to be the nucleus. Based on these observations, Ernest Rutherford came up with 3 conclusions. So most alpha particles went straight through the gold foil because the atom is mostly empty space. Some alpha particles were deflected from their path, they changed direction, as you can see here, and that was because there is a strong positive charge in the nucleus and they're both repelling. Remember we said alpha particles are positive, the nucleus is positive, and it's dense all of the positive charges inside the nucleus, so they're both repelling each other. And a small number of alpha particles were deflected straight back by 180 degrees. And the conclusion for that is that most of the atom's mass is in the nucleus, and that's what's causing those relatively big alpha particles to come right back and be deflected. So this is the model that Ernest Rutherford had, the positively charged dense nucleus that has most of the atom's mass, and the electrons are like orbiting like planets in a solar system. The next person you need to know about is Niels Bohr. So in 1913, Niels Bohr realized that because the electrons are negative and the nucleus is positive, those electrons will quickly spiral into the nucleus and collide with it, and the atom will be destroyed. But obviously we know the atom exists and is stable. So he used a mathematical model to prove that electrons exist in fixed shells or energy levels, and these shells are certain distances away from the nucleus. So this is Bohr's atomic model. Later on, scientists discovered that the positive charge inside the nucleus is actually made up of smaller particles called protons, and these are positively charged. So far they've discovered electrons, they discovered the protons, that is giving the nucleus a positive charge. The only particle left is a neutron. The neutrons were discovered by James Chadwick in 1932. He discovered small particles that have no charge but a mass, and these are neutrons. Here's a summary of how the atomic model has been developed.